Okay, let's see. Let's do some examples now. How many common tangents are there in A, B, and C? How many common tangents are there in A, B, and C? Well, this is a question that we're going to have to refer to our notes on. So if we hold up the notes here, number, I'm sorry, where we talk about common tangents. If we look at right there, of course it's backwards in your screen, but we've got two types of common tangents. Alright, the one where that goes kind of between the circles and the ones that go outside the circles. Okay, so let's using that knowledge, let's look at where our common tangents might be. First, we've got one here on the outside of the circles. That's one. Okay, we've got another one. If we go to the other side of the circles, we've got one there too. That's two. And then we've got those inside ones. So if I've got one going here to here, that's one. And then if I've got another going here to here, that's another one. Okay? So in this one we've got four. Four common tangents. If we move down, let's look at B. B, it looks like I'm only going to have a couple. I can't go in between. Oh, excuse me. Yes, of course I can go in between. So it looks like I'm going to have maybe not four, but if I send one going between the circles, that's one. If I send one going to the outside of the circles, that's two. If I send another one, maybe another color here just to differentiate, going to the outside of the circles, that's three. So I've got three tangents on part B. Three. Alright, in number C, number C, on letter C, let's see how many tangents I've got in this one. Now this one I can't go between because that would be secants, right, where they go through 2 points right here and here. So I can't go in between them, but I can go to the outside. So here's one right here, and here's another one right here. Okay, so this one would just be two common tangents. Okay, and that's it. Now, let's move over to the example to the right here. This one, I want to find x, as usual. Find x. Where is x? That's our goal. So let's find it. I know that if AS is tangent to circle C and so is AT, that these segments must be congruent. That's my last theorem on the other page there. I know that those things must be congruent. So to find x, I just say, hey, I bet you 3x plus 4 equals 28. And then I subtract 4, I get 3x equals 28. And then, I'm sorry, yeah, 3x. Divide by 3, and I'm going to end up with x equals, oh, I'm sorry, geez, oh, Pete, 24 divided by 3, excuse me, 24 divided by 3, and that means x equals 8. Okay, 24 divided by 3, x equals 8. I apologize for the mistake there. Let's move on to the next example. Let me just change the picture here on your screen. And moving along. Don't worry. The anticipation is killing you. Okay, here we go. So let's do some examples here then. Is ST a tangent? So if I want to look at this picture here, and I want to find out, is ST tangent to the circle? Well, I know that ST will be tangent if this angle right here is 90 degrees, is a right angle. Okay? So if the, oh, I guess I can move my mouse even. If ST and TP form a right angle, if they're perpendicular, then it's a tangent. That means that this side here, SP, must be the hypotenuse of the right triangle if it's tangent. Okay? So that would mean that I could use a squared plus b squared equals c squared to figure out if ST is tangent. If That is true. If the Pythagorean theorem is true, then I know it must be tangent. Let's try it. I know that c must be 37. This must be my c over here. So c squared equals a squared plus b squared. Well, it doesn't matter what we pick for a. How about 12 squared plus 35 squared? Okay. So 12 squared plus 35 squared equals c squared. Oh, excuse me. Let's actually put in c. C is going to be 37. Okay, so 37 squared. And then I want to actually do the math on this, and I'm going to find that that ultimately you get down to 1369 equals 1369. Little calculator action there. You figure out that that is true. So this, so yes, ST is tangent. Okay, let's move on to the next example. Okay. Now in this one, I know the picture is kind of hard to look at, but here's what we've got going on. I've got R is a radius. Okay, so these two little R's are my radii. Okay, and then I've got a right angle down here at B. B is a right angle. Okay, so I've got that going on, and I want to find out I want to find the length of R. So I want to find, I'm going to use yellow. I want to find the length of R. So find R. Okay. To do that, once again, I'm going to use the Pythagorean theorem. AP squared, that's my hypotenuse, is going to equal one leg. How about 80 squared? I'm sorry. How about AB squared plus PB squared? Okay, which is that last short leg over there. Alright, well, I know that PB is R. Okay, so I know that PB is R squared plus AB squared. Well, AB, that's 80 squared. And then the tricky part, what is AP squared? Well, I can look over here and I see that AB looks like it's 50 to get to there plus R to get to P. Okay, so 50 plus P is what my, 50 plus R is my length. 50 plus R, that whole thing squared. Okay, 50 plus R, the whole thing squared. Okay, so now I've just got some fancy math to do here. And you guys learned in Algebra 2 how to expand this stuff on the left. So I'm going to get 80 squared here plus R squared. On the left, I'm going to get 2,500. Okay, 2,500 plus, you know what, I'm sorry guys, I'm going to have to write this a little bit lower. 2,500 plus 100R plus 25 squared plus R squared. Okay, so that's what I'm going to get on the left. Alright, and then let's let's move this whole thing. Let's move this whole thing up here. Okay, so maybe you can write this a little bit neater. So here's what I've got: 2,500 plus 100R plus R squared equals plus R squared equals 80 squared plus R squared. Okay, what's going to happen is the R squareds are going to cancel each other out. You got an R squared on both sides, they cancel out. So I'm going to have 2,500 plus 100R equals 80 squared. When all the math shakes out on this, you're going to get down to, so this is just a one-step or a 2 to 3-step equation here. I'm going to get down to R equals 39. Okay, the most important step being this one, finding that 25R plus 100R plus R squared equals 80 squared plus R squared, and the R squareds drop out. And that's it for section, 10.1. So hopefully your introduction to circles is okay, and we're ready to do the homework for chapter 10.